morning? Good morning, good evening, both okay, no problem. Yeah, okay. So everyone, Manchi? Yeah, okay, very good, very good. I'm also okay, no problem. Yeah, today combined class is there for online students also, offline students also. You see, online students are getting jealous of all of you. They are saying, why offline students are there, sir? Yeah. So today both batches are there. Online is also there, offline is also there. So every batch is there. Yeah. Because in morning I did not take the class due to little cold. Okay, no problem. But now it's okay. No problem. Yeah. So, okay. So everyone settled down in yellow, dynamic yellow star. People are still roaming. Come on. Uh, ah, still people are. Just break happened. Just now break was there. Huh? Okay. Okay. How many time? Means how much time duration? 2 hours. 2 hours break. Acha. Half an hour. Okay. Okay, no problem. That is enough. That is enough. Okay, no problem. Yeah. Okay. So online batch is also there. Offline batch is also there. So all online batch and all offline batches are together. So because we'll be studying same thing. Okay, no problem. So I think in last class we were talking about, okay, no problem. So online students can give answer by typing, offline student can give answer by symbol. Yeah, okay, yeah. Parents also there. I saw some people were saying hi and bye to parents. Which type of communication is going on? Parents also hi and bye was going on. I was seeing that. Yeah, okay, no problem. Yeah, okay. So now let's start with the class. Acha, one thing I will tell you. One thing I will tell you in online batch. Okay, yeah, okay. I remembered. Yeah, in online batch we have not studied about tangent galvanometer. In online batch also we have not studied, and in yellow star batch also we have not studied about tangent galvanometer. So you can leave one page for it. You can leave one page for tangent galvanometer. We will study in the next class, where we'll study having class separately. At that time, we'll be studying about tangent galvanometer. So yellow star batch, yellow dynamic batch, and our online students, leave one page for tangent galvanometer. Write the name of topic. Otherwise, you'll do some rough work there. Yeah, so write the name of topic, tangent galvanometer. That page belongs to tangent galvanometer. So write topic name tangent galvanometer and leave that page. We'll study about that in our next class. Yeah. Is it okay? Online students okay? Offline students are very happy. You see how much happy they are. Yeah. Yeah. Okay. Okay. No problem. Yeah. So now we are going to start with our, okay, now be focused. We are going to start with one new chapter. Actually, in last class, we completed one chapter. We completed moving charges and magnetism. Today, we are going to start with our next chapter. Yeah, okay. If you are clapping, nice. Come on, everyone clap. One chapter is completed. No one is clapping. Only a light star is clapping. Yeah, okay, no problem. Okay, yeah. So now we will start with our next chapter. We are going to start with our chapter electromagnetic induction. So you write the name of the chapter electromagnetic induction. Electromagnetic induction, EMI. We are going to start with our chapter electromagnetic induction. One thing is left, tangent galvanometer. It is not in NEET syllabus also, okay, but still, okay, no problem. We'll study that in our next class. So we are going to start with our next chapter, that is electromagnetic induction. Very important chapter, very conceptual chapter. 2 questions will be asked from here in your NEET exam, and those questions will be able to solve only if you understand the concept. And this chapter starts with one law. This chapter starts with one law. This chapter starts with one observation, that is Faraday's law. So you write Faraday's law. Faraday's law. The way we have Sunday, the way we have Monday, in the same manner we have Faraday. Okay, no problem. The way we have Sunday now, Sunday, Monday, Tuesday, Faraday. So this chapter starts with one law, which is very, very important. That is our Faraday's law. And whole of the chapter will be revolving around this only. Actually, this Faraday law is actually Faraday's law of electromagnetic induction. So whatever you will study in this chapter, that will be associated only with one law, that is our Faraday's law. So we'll be talking about this Faraday's law. So first you write the statement. You write, Faraday observed that Faraday observed that whenever magnetic flux associated Faraday observed that whenever magnetic flux associated through a coil changes, Faraday observed that whenever magnetic flux associated through a coil changes, an EMF is induced in the coil. Faraday observed that whenever magnetic flux associated with a coil changes, an EMF is induced in the coil. And if the circuit is closed, whenever magnetic flux associated through a coil changes, an EMF is induced in the coil. And if circuit is closed, induced current, and if circuit is closed, induced current will flow in the coil. And if circuit is closed, induced current will flow in the coil. So this is the observe. This is actually not your Faraday's law. This is observation of Faraday. After doing many experiments, Faraday went to final conclusion that whenever magnetic flux associated through a coil changes, an EMF will be induced in the coil. This your coil will start behaving as a battery. Till now you studied about battery generates EMF. Here coil will generate EMF. So what Faraday observed after doing thousands of experiments, Faraday went to final conclusion that whenever magnetic flux associated through a coil changes, an EMF is induced in the coil. And if your circuit is complete, always remember EMF will not give you current. If you want induced current, your circuit must be closed. So if your circuit is closed, induced current will flow in the coil. So first thing you tell me what Faraday observed. What was the observation of Faraday? Whenever magnetic flux, come on, everyone will say, what is the observation of Faraday? Whenever magnetic flux associated through a coil changes, an EMF is induced in the coil. And if your circuit is completed, induced current will flow in the coil. Now, so this was the observation. Now we will talk about value. Actually, Faraday law gives us value of that induced EMF. Now you change the paragraph and you write the statement of Faraday. Right? Value of induced EMF in the coil, will be equal to rate of change of magnetic flux. Value of induced EMF in the coil will be equal to rate of change of magnetic flux and direction of induced current. Value of induced EMF will be equal to rate of change of magnetic flux and direction of induced current will be opposite, to the cause which produces it. And direction of induced current will be opposite to the cause which produces it. And this is also explained with the help of Lenz law. In bracket about direction, we'll study one law separately, which is Lenz law. So in bracket, you can write Lenz law. Yeah. So just see here what I'm trying to tell. Be focused, bring understanding, because whatever we'll study in this chapter will be based on Faraday's law. So what happened? Faraday was doing many experiments. After many experiments, Faraday went to one conclusion that whenever magnetic flux associated through a coil changes, an EMF is induced in the coil. But EMF don't give you current. For current, you need a closed circuit. So that's why he said if circuit is closed, induced current will flow in the circuit. Then he said, what will be value of that induced EMF? You are saying that, sir, Faraday is saying that induced EMF will be there, induced EMF will be there. So what is value of that induced EMF? And value of induced EMF was given by Faraday's law. That is, value of induced EMF will be equal to rate of change of magnetic flux. And direction of induced EMF, direction of induced current will be in such a manner that it will oppose the cause, which is also explained with the help of Lenz's law. I'm giving you time of 10 seconds. Come on, revise this part. See this part. Whenever magnetic flux associated with a coil changes and EMF is induced in the coil, and if circuit is completed, induced current will flow. Induced EMF will give you induced current. And value of induced EMF will be equal to rate of change of magnetic flux. And direction will be opposite to the cause which will produce it. So see here what we are going to talk. Okay, no problem. So this was the statement. Now how to write that statement in numerical form? Because we are going to get numerical from there. So what Faraday says like this: induced EMF will be equal to rate of change of magnetic flux. Rate of change of magnetic flux. We represent magnetic flux by phi B. If you remember, electric flux we represented by phi E, magnetic flux we represent by phi B. And direction of induced EMF will be opposite to the cause which produces it. So that's why we put minus here. Whenever we write induced EMF, this is the value of induced EMF. Whenever we write Faraday's law, we always put minus here. This minus indicates that direction of induced current, direction of induced EMF will be opposite to the cause which produces it. This is the Faraday law. Induced EMF will be equal to rate of change of magnetic flux, and direction will be opposite to the cause which produces it. First you write this. Now always remember, yeah, okay. So this is the value of induced EMF. Whatever you have written in the form of language, I'm writing same thing in the form of equation. Okay. First thing, you tell me why that minus is there. Why that minus is there? Why Faraday's law induced EMF is not equal to rate of change? Why we are putting minus there? Because induced EMF will always oppose the cause. Induced current will always oppose the cause, which we also explain with the help of Lenz's law, which we'll study in our next class. That's why that is the significance of that minus. Now be focused, understand. Acha, always remember, whenever we talk about any quantity associated with rate now, we have two types. If you remember, velocity is rate of change of displacement now. That's why we talk about two type of velocity. Instantaneous velocity, average velocity. The same manner, rate, induced EMF is rate of change of magnetic flux. So your EMF will be also of two types. One will be your instantaneous EMF. If anyone asks you at a particular instant, that is our instantaneous EMF. And that instantaneous EMF will come with the help of differentiation. And what was your instantaneous velocity? Dx by dt now. What was your average velocity? Delta x by delta t now. In the same manner, since your EMF is coming with the help of rate, every quantity associated with rate will be of two types. So same way, your EMF will be also of two types. Instantaneous EMF will come with the help of differentiation. That is rate of change of magnetic flux. That is differentiation of your phi B. And average EMF will come minus of delta phi B by delta t. That means you can say minus of final flux minus initial flux upon delta t. You can write as delta t will be coming as T2 minus T1. So this is how we calculate instantaneous EMF, and this is how we calculate average EMF. First write this. Same Baba, instant. Why minus is there? Again minus. Why I'm using minus? Because direction of induced current, direction of induced EMF will be opposite to the cause. That's why that minus we put there. Yeah. So two types of the way velocity was rate of change of displacement. We got two type of velocity, instantaneous velocity ds by dt, average velocity delta h by delta t. In the same manner, we get two type of EMF, that is our instantaneous EMF, which comes with the help of differentiation minus d phi by dt. Average EMF comes with the help of delta phi by delta t. And minus just indicates that direction of induced EMF, induced current, is opposite to the cause which produces it. So this is what we have here. This is what we have here. But always remember, in order to understand this induced EMF, we must know about magnetic flux. So first we will again talk about magnetic flux. After talking about magnetic flux, we'll start doing numericals from here. You write magnetic flux. Yeah. In the same manner, electric flux, magnetic flux, both are same thing. One is due to electric field, one is due to magnetic field. Yeah, okay. So just here how we represent magnetic flux. The way we used to write electric flux, E dot S. In the same manner we write magnetic flux, we write phi B. Phi B will be coming as B dot S. B dot S. Okay, no problem. Or you can simply write this as BS cos theta. Where theta is, yeah, this is the value of magnetic flux that we get. And you know what is your S? S is your area vector. And this area vector will be S is your area vector, and you know this area vector will be always outward perpendicular to the surface. Same thing that we studied in electric flux. Nothing changed. First you write this, but there is one difference here. Yeah. So area vector will be always outward perpendicular to the surface, outward normal to the plane, outward perpendicular to the surface, or you can say outward normal perpendicular to the plane. Now always remember, yeah, okay, so this is the value of our magnetic flux. The way we say electric flux is E dot S. In the same manner, magnetic flux we say B dot S. That is our BS cos theta. And always remember, S is our area vector, which will be outward perpendicular to the surface, outward normal to the plane, which we have already studied. Now be focused 100%, just here. Always remember, in electrostatic, we always talk about single turn. But in magnetism, we always talk about coil. Coil can have any number of turns. The value of flux which you are seeing here now, this is the flux associated with a single turn. If someone says, sir, n turns are present in the loop, I'm saying, sir, n turns of the loop are there. So for each loop, same flux will come now. So if n loops are there, it will become n times. So always remember, for n turns, if I'm saying, yeah, for n turns, if your coil has n turns, then total flux associated through your coil will become, n times of this. That is n times of BS cos theta. So first you write this. So total flux associated through a coil of n turn will be coming as NBS cos theta. NBS cos theta. But what happens, students find difficulty. I also find difficulty to say it every time. NBS cos theta, NBS cos theta. Does it feel good? Some rhyming comes, NBS cos theta, NBS cos theta. So what I will do, how you will write, okay, the way how you will remember, just here I will be talking about. Actually, here we represent S by A. S is also area vector. I can represent area vector by A also or by S also. So if you represent this area vector by A, this result will become easy to say, ban cos theta. You can now say very easily, so total flux associated through a coil of n turn will be coming as ban cos theta. Even you are sleeping, you can say this word now. I'm sleeping, someone has total flux associated with a ban cos theta, ban cos theta, ban cos theta. So that's why here we represent S better with A. So this relation becomes very easy to say. First you write this. S is area. Area you can represent by A. Better na. So it becomes easy for us to say. And little stylish also. Ban cos theta. Ban cos theta. Ban cos theta. Okay. Yeah. Yeah. So always remember, if anyone asks you find the flux associated through a coil, we can directly say. So for n turns, it will be coming as ban cos theta, where B is magnetic field, A is area, N is the number of turns, and theta is our angle between area vector and B vector. For example, just see here. I'll just give you idea. Okay, no problem. For example, someone says, sir, I'm having a coil like this. Same thing we did in electric field also. So just see here. Someone is saying, sir, I'm having a coil like this. And here magnetic field lines are like this. This is your B vector. Okay, no problem. And if you see its area vector will be like this. I'm saying its area vector is S vector. Okay, no problem. So if anyone asks you what is flux here, so you can find very easily. You can see angle between your area vector and magnetic field, that is 90. So flux will be coming 0. If you calculate flux here, same thing we did in electric field also, that is will come Bs cos 90. So that will be giving you flux 0. But you tell me what will be the flux here? Come on, Chepandi Twarga. Yeah, here maximum flux will come. Because your area vector will be also like this, B vector also like this. So here theta will be coming as 0. That means flux will be simply coming as B into S. First write this, come on. First write this. That is the meaning of zero flux. That is the meaning of maximum flux. So just I was trying to bring understanding what is meaning of zero flux and what is meaning of maximum flux. Okay, no problem. Yeah, okay. Now understand. Achha, tell me when flux will be maximum? When magnetic field is perpendicular to the plane. These are also things which are asked. Theta is, always remember, students make mistake here. Students think our magnetic flux will be maximum when theta will be 0. Theta will be 0 means parallel. No. But theta is not angle between plane and magnetic field. Theta is angle between area vector. You write this point, come on. A coil will have maximum flux. In perpendicular magnetic field. A coil will have maximum flux in perpendicular magnetic field. Because a coil will have maximum flux in perpendicular magnetic field because B vector and S vector, both will be parallel. A coil will have maximum flux in perpendicular magnetic field. Because B vector and S vector, you can see here magnetic field. Always remember, theta is not the angle of magnetic field with the plane. Theta is the angle between S vector and area vector. S vector and B vector. So always remember, when S is already perpendicular to the plane. So to get angle 0, your B should be also perpendicular now. So always remember, your magnetic flux will be maximum when your B magnetic field is perpendicular to the plane. Next point you write. Flux is minimum when B is parallel to the plane. Flux is minimum when B is parallel to the plane. You can see here B is parallel to the plane. Area vector is perpendicular to the plane. So how much angle will come here? Here angle will come 90. So that's why your flux will be minimum. So first thing you tell me, you have to keep this thing in your mind. Important question. When coil gets, if I say, you tell me for flux to be maximum, what should be the angle between B and S? Yeah, 0 degree. B and S 0 degree. But magnetic field and plane, yeah, perpendicular. Because magnetic field perpendicular to the plane, area vector also perpendicular to the plane now, then only both will come in the same direction, then only theta will come 0. So you tell me when flux associated through the coil will be minimum. When magnetic field will be parallel to the plane. Because when field will be parallel, area vector will be perpendicular. Angle between them will become 90. So flux will become 0. So this is how we talk about. I will give you one question. Come on, right? Right. A square coil of side length, a square coil of side length 2 meter. A square coil of side length 2 meter is placed. A square coil of side length 2 meter is placed in XY plane. A square coil, this is a good question, bring understanding. A square coil of side length 2 meter is placed in XY plane. If magnetic field is 2I cap plus 3J cap plus 4K cap Tesla, if magnetic field is 2I cap plus 3J cap plus 4K cap Tesla, find flux through it for 100 turns. Find flux through it for 100 turns. Yeah, okay, very good, very good. Don't do mistake. A is side length, not area. A is side length, come on. A side length of a square is given. First find area. Yeah, 1600 will come. Answer will come 1600. Yeah, correct, very good. See, online students are giving answer fastly than offline. Oh. Yeah. Okay. Okay. So again, we will say in the same manner. For 100 turns, they are asking you, you can say very easily, I'll be simply saying, sir, yeah, always remember, be focused, understand. Always remember, when magnetic field vector is given now, you cannot find flux directly. You have to always write area vector. Always remember, if magnetic field vector is given, you have to write area vector, then you have to use dot product to get the total number of flux. I'll be simply saying, sir, flux for one turn, I know, sir, that will come, sir, B dot S. So B vector given now already, S vector you have to find. And for S vector, you know, what is your area? This is a square loop of side length 2 meter now. What will be its area? Area will be 2 square. Side length of a square is 2, so 2 square. So area will come 4. And what will be direction of area vector? Area vector will be perpendicular to the plane. Object is placed in XY plane. So perpendicular, who is perpendicular to XY plane? Yeah, Z axis. Your area vector will come along Z axis. So your area will become 4K cap. Bring understanding. Bring understanding. This is an important question. What happened in classroom? AC is not working. Huh? Yeah. Why? Chadda people. Yeah. Okay. That's why Sri Chaitanya rocks. Yeah. That's why I'm finding everyone is using fan. Yeah. Focus on study. That is more important. Yeah. So always remember. Okay. Okay. So always remember, whenever magnetic field is given, whenever magnetic field vector is given, find the area vector. And for area vector, first find the magnitude of area. So size square side length 2. So what will be magnitude of area? Magnitude of area will be 4. Array 2 square 4. And what will be its direction? Perpendicular to the plane now. In which plane object is placed? XY plane. So what will be its direction? Perpendicular to XY plane is your Z axis. So your area vector will come 4K cap. And you know flux will be coming as, this is for one turn, B dot S. You know, I will give dot only with I, J with only J, K with only K. So if you do the dot product, this K and K will only give you dot product. So 4 into 4 will give you 16. This is for one turn. For n turns, total flux will become 100 into 16. That will come 1600 WB, Weber. That is our unit of magnetic flux. Everyone understood? Yeah, okay. If you don't know how to do dot product, don't think you will be able to solve. Yeah. Who gives dot product with whom you must know? I will give dot with I, J with J, K with K. No IJ is there now. Only K is there now. So KK will give you dot product. So 4 into 4, 16. Do one more question. Come on, you write. I'm giving magnetic field. and I'm giving you area. This is XY plane. This is a circle of radius 1 meter placed in XY plane. Tell me the flux through. This is one turn only. Tell me the flux through the circle. First find area. Find area of a square. B vector given, find S vector. Area vector. Find magnitude of area. It's a circle now. What is area of circle? Pi r square. So pi into 1 square. This is your area. And what is its direction? It is placed in XY plane now. So what will be its direction? Its direction will be along K cap, perpendicular to the plane. That is K cap. That means your area vector will come pi K cap. Now once you got the area, you have the B, and you know K will give dot only with K. So from there, if you calculate the flux, yeah, that will come pi K cap and 3 K cap. That will give you 3 pi WB, Weber. Chamki baat, bolo bolo. Everyone understood? Raise your hands. Yellow star. Yeah, a very inactive student. That's why I'm wearing yellow t-shirt for all of you only. Yellow star and yellow dynamic. Yeah, okay. A light star and a light dynamic, no color exists. That's why I did not wear. Yeah, okay. A light, no color is there now. I'm giving you time of 10 seconds. Come on, say all these things. So always remember, whenever magnetic field vector is given, write area vector. For area vector, first write the magnitude of area. Pi r square, here circle, previously square, so side is square. Then write area vector with the help of concept area vector will be perpendicular to the plane. You write one more question. Come on. Varga, come on, do fastly. Right. If magnetic flux changes as phi b equal to t square plus 2t plus 4, if magnetic flux changes as phi b equal to t square plus 2t plus 4, find induced EMF at t equal to 1 second. Find induced EMF at t equal to 1 second. Yeah, okay, very good. Online students can say answer. 4. Yeah, 2 and 2. Okay. This is not 2. This is not 2 in my class. In my class, 2 means this. So 2, 2, 4. Yeah, okay, no problem. So EMF will be coming. You can find EMF now. First thing, you tell me which EMF they have asked you. Which EMF is asked? Instantaneous. They're asking you find EMF at t equal to 1 second, means instantaneous EMF. Instantaneous EMF will come minus d phi by dt. So differentiate your flux. So if you differentiate t square, it will give you 2t. 2t differentiation will give you 2, and 4 differentiation will give you 0. Now from here, what they're asking you, t equal to 1 second. So put the value of t1 here. So minus, this will become 2 plus 2, that is 4. So answer will come minus 4 volt, not 4 volt. First, you will search for this option. If minus 4 volt is there, that will be correct answer. If it is not there, then you will go with answer plus 4. Are you getting the idea? Some people do silly mistake here. In exam, they will give you plus 4 also in the option, minus 4 also. So always remember, first go with the minus option. Then only think about it. You write one more question. Come on. You write. Find the time when EMF induced. Find the time when EMF induced in the coil will be 0. Find the time when EMF induced in the coil will be 0. Find the time when EMF induced in the coil will be 0. Yeah, okay. Yeah, answer will come. EMF induced in the coil will be 0. That means first write the value of EMF d phi by dt. How much it will come? This will be coming as, sir, minus of. If you differentiate, this will give you 2t minus 2. This 10 differentiation 0. EMF will be 0. So equate it to 0. So t will be coming as 1 second. Chamki baat. Everyone will be able to do this type of question. If flux is given, they will ask you, will you be able to do? Acha, if I ask you average, then what you'll do? If I ask you find, come on, do question, right? Find average EMF. Find average EMF from t equal to 0 to t equal to 1 second. Find average EMF from t equal to 0 to t equal to 1 second. Normally average is not asked, but you can do. Yeah, okay. At first, always give preference to negative answer if it is coming from the numerical. Yeah. So average EMF means, sir, minus of, come on, leave your copy. Leave your copy. Sir, average EMF means minus of delta phi by delta t. Definitely question will come in your NEET. Faraday's law is very, very important. So many times question has been asked. Sir, minus of delta phi by delta t. Delta phi means final flux. Final flux means when time is 1 second. Minus initial flux, that means when time is 0. Upon T2 minus T1, that is 1 minus 0. Now just put, you can find the flux when T 1 second, put the value of T there, put the value of T1 there. So 1 minus 2, that is 9. This will give you 9 minus. You can put the value of T1. So 1 minus 2 plus 10, 11 minus 2, that is 9. Minus this you can write 5 at 0. Put T equal to 0. So if you put T equal to 0, this will give you 10 by 1. So this will give you minus of, this will give you minus 1 by 1. So your final EMF will come plus 1 volt. This is the answer. If it is coming plus 1 from here, then that will be your answer. So always give preference to, don't ignore this minus. Every time don't ignore minus. Because if plus minus option is there, you have to be careful. Chapki baat. I'm giving you time of 10 seconds. Come on, see all this type of numerical. Come on. Come on, everyone will say how you calculate instantaneous EMF. How instantaneous EMF? E instantaneous will be equal to minus of d phi by dt. Come on, say E instantaneous will be equal to minus of d phi by dt. E average will be equal to minus of delta phi by delta t. Minus of delta phi by delta t. Now understand how we'll be talking about. Just see here. How we'll be talking about. Acha, you tell me. Now be focused. Understand. Acha, you tell me. For EMF, what is important? Flux is important or change of flux is important? What is important? Change of flux. Having flux never gives you EMF. That is the rate of change of flux. You write this point. We'll be moving towards numerical from there. You write for induced EMF, rate of change of flux is, for induced EMF, change of flux is important, not flux. For induced EMF, change of flux is important, not flux. Always remember, if a body have very large flux, doesn't matter. EMF will not come due to magnetic flux. EMF will come due to change in flux. And if you see the value of flux, which I just told you now, that value of flux came ban cos theta. And always remember, I'm not interested in this flux. You tell me, does we are interested in flux for EMF? No. For flux, for EMF, we are interested in change in flux. And this flux depends on 3 factors. From where question is asked. What will happen sometimes, what they will do, they will say magnetic field is changed. If you change the magnetic field, flux will change, EMF will come. In some question, what will happen, they will change the area. They will say initially it was a square, now it is circle. Area will change, flux will change, EMF will come. Number of turns never changes. Sometimes they will rotate the coil. If you rotate the coil, theta will change. If theta will change, again flux will change. Again flux will change, EMF will come. So always remember, questions are asked from these 3 factors. In some question, they will change magnetic field. In some question, they will change area. In some questions, they will change angle. So how to deal with all those situations? I will give you one question. Come on. You write a square coil, a square coil, a square coil having 100 turns, a square coil having 100 turns, a square coil having 100 turns and side length and side length 10 centimeter is placed. A square coil having 100 turns and side length 10 centimeter is placed in perpendicular magnetic field. Is placed in perpendicular magnetic field. Is placed in perpendicular magnetic field, which changes with time. Which changes with time as B equal to T square. A square coil having 100 turns and side length 10 centimeter is placed in perpendicular magnetic field which changes with time as B equal to T square. Find induced EMF. Find induced EMF in the coil at T equal to. Find the induced EMF in the coil at T equal to 2 seconds. Find induced EMF in the coil at T equal to 2 seconds. First thing you tell me, what is angle between area vector and magnetic field? What is angle between area vector and magnetic field? Does angle is 90? Does angle is 90? No, angle will be either 0 or 180, which will not change your answer. Only plus minus difference will come. So first write the total flux. They differentiate that flux. You'll get the EMF. Put the value of time. Yeah. At T equal to 2 seconds. First convert in SI system. Side length of a square will come 0.1 meter. Now write the flux. You know flux will be coming as, sir, for n turn we know ban cos theta. What will be theta here? What will be theta here? Either 0 degree or 180 degree. Perpendicular to the plane can be this also, can be this also. So either 0 or 180, your answer will not change, only plus minus will come. So they will not give you such option at that situation. So I'll be simply saying, sir, theta will come 0 if we take. So from here I can say flux will be coming as ban. So what is B? B is your T square. What is area of a square? Side square. That is 0.1 square into n. What is the number of turn? Number of turn is 100. And what is cos theta? Cos theta will come either 0 or 180. That will give you either plus 1 or minus 1. They will ask you magnitude of EMF. So you can ignore plus minus now. Now this is the flux. If anyone asks you EMF, you know EMF is minus d phi by dt. But here they will ask you magnitude of EMF. So that's why you can ignore again minus from there. So now how much it will give you? If all these things are constant, if you differentiate T square, it will give you 2T. And this will give you 0.1 square will give you 0.01 into 100. Now from, yeah, very good. Many people were saying the answer also. So final answer will come for EMF at T equal to 2 seconds. You can put the value of T. This will give you 0.1 into 100 will give you 1. Put T equal to 2. So 2 into 2. How much answer will come? 4 volt. 4 volt. Answer will come 4 volt. Hey Bhagwan. Yeah, answer will come 4 volt. And in this type of question, plus minus will not be given. They will simply ask you magnitude. Come on, do one more question. Come on, fast. So some questions will be asked like this. They will give you diagram. You write. You can see we are having a circular loop. I'm saying radius of this circular loop I'm giving as 2 meters. And please don't write area of circle wrong. Yeah, People are writing area of circle also. There I did a square. Now here also they are writing area of circle as r square. There sir is doing a square. Here r is there, so r square. Please, come on. Magnetic field is given. Magnetic field I am giving as, for example, t cube by 3. With time, t cube by 3. Magnetic field is changing. Magnetic field is varying. Number of turns I am giving as 1 turn. If nothing is given, you will take 1 turn. You tell me how much EMF induced at t equal to 2 seconds. Come on. Tell me EMF induced at t equal to 2 seconds. Yeah, okay, very good. Come on, find. Yeah. Don't do mistake. Again, first write the value of flux. If you know flux, then only EMF will come with the help of differentiation. They are talking about instantaneous EMF. So again, we will first calculate flux, sir. Flux will be coming as ban cos theta. Either theta will come 0 or 180. So 0, 180, either plus will come or plus 1 or minus 1. You can ignore that. So we'll be simply saying, sir, this will give us ban. What is B? B is given as t cube by 3. And what is area? Area of a circle, that is pi r square, that is 2 square, into n. What is n? N is 1. So this is the flux that you got, but they are not asking you flux, they are asking you EMF. EMF will come d phi by dt. So if you differentiate it, what will happen? Here you will get 3t square by 3 into pi, and 2 square will give you 4. This will get cancelled. That means you will get 4 pi into t square. When they're asking you t equal to 2 seconds, put the value of t there. So this will give you 4 pi into 2 square. That is also 4. So answer will come 16 pi volt. Chamki baat bolo, bolo, bolo. Everyone understood? Yeah, okay, okay, yeah. So this is how we can talk about, and this is how we can do very easily. So always I'm giving you time of 10 seconds. Come on, see all this situation. I think 6 o'clock they will provide electricity now. Normal break timing is from 5 to 6 now. I think during that time they will yeah, switch off the AC and everything. It's not like that. Then why AC is off? Acha. Some unknown reasons. Yeah, okay. So this is how we can talk about. So always remember, again, be focused. Yeah, okay, come on, be focused, understand. First thing, always remember, we get 2 type of EMF: average EMF delta phi by delta t, instantaneous EMF d phi by dt. Sir, phi will be equal to ban cos theta. So if B will change, we can do. If B will change, we can find out. Sometimes area will also change. Come on, you write one question. Come on. You write. A circular coil is placed in perpendicular constant magnetic field. A circular coil, very good question, previous year question. A circular coil is placed in perpendicular constant magnetic field of 10 Tesla. A circular coil is placed in perpendicular magnetic field of 10 Tesla. If radius of circle started increasing, at a rate of 10 centimeter per second, if radius of circle started increasing at a rate of 10 centimeter per second, find the induced EMF. If radius of the circle started increasing at a rate of 10 centimeter per second, find the induced EMF. When radius becomes, find the induced EMF when radius become 1 meter. Find the induced EMF when radius become 1 meter. If you see here, magnetic field is constant, theta is 0, number of turns is not changing, but your circle radius is increasing, that means area is increasing. If your area is increasing, flux is increasing. If flux is increasing, EMF will come. So they are asking you find induced EMF when radius becomes 1 meter. Again, same process, write the value of flux. Okay. It's a circle, area will be pi r square, but you cannot write radius 1 because radius is continuously changing. Okay, very good. Come on, leave your copy. Be focused here. Those who are not getting, be focused here. Learn from here how to do this type of question. First thing, always convert into SI system. So 10 centimeter per second now. So we will write this as 0.1 meter per second. And I will write the value of flux. Flux, I know, sir. Flux will be coming as man cos theta. So this flux will be coming as how much B is given? B is given constant 10. Area of circle I know, sir, pi r square, but I don't know r because this radius is continuously changing. At any time I'm saying the radius will be r. So that's why area of the circle at that time will be pi r square into n. Nothing given, that means number of turns will be 1. Cos theta will come either 0, theta will come, or 180, that will give you either plus 1, minus 1. We are not interested in that. We are just talking about magnitude. So theta will come 0 or 180, so it will give you magnitude 1. So this is the value of flux. Flux at any time when radius is r, that is coming, sir, 10 pi r square. Now what they are asking you, EMF. EMF, be focused, just see how I will do the differentiation. Sir, EMF means they are asking us EMF, I know, sir. Magnitude of EMF is required, so E will be coming as, sir, d phi by dt. Now if you differentiate it, this will give you 100 pi. R square differentiation you can do. R square differentiation you can do with respect to time. You can write this R square differentiation as 2R into dr by dt. This is how we'll differentiate R square. We are not differentiating R square with respect to R. You have done this type of differentiation in ray optics. Array 1 by V minus 1 by U equal to 1 by F. There you differentiated with respect to time. So 1 by U square into du by dt. Same thing will happen here. If you differentiate R square, it will give you 2R into dr by dt. Now from here it will come. Yeah, this will become. Now you can put. This is the value of EMF. Now when they are asking you EMF, when radius become 1. So put there 10 pi 2R. What is radius? Radius is 1 when they are asking you. And what is dr by dt? That is given as 0.1. Now from here you can find this, you can remove. This will get cancelled. So this will give you finally, how much it will give you? 2 and pi is left. So this will give you 2 pi volt. This is your answer. This is the EMF induced. First you write this, come on. Did you understand that differentiation? R square differentiation will give you 2R into dr by dt because you are not differentiating R square with respect to R. What is differentiation of R cube? Just see here. R cube differentiation is 3R square only when you differentiate R cube with respect to R. Then only it will give you 3R square. If you are differentiating R cube, with respect to time, then it will come like this. This is what we are doing. dr cube by dr into dr by dt. Chain rule, if you remember, we studied in the beginning. So this is giving you 3R square and this is giving you dr by dt. Same thing I am doing there. Pi r square, differentiating pi r square. So R is not R is not constant. So R square differentiation will give you 2R into dr by dt. I'm giving you one more question. Come on. You right? You right? a square is kept, a square is kept in perpendicular magnetic field. A square is kept in perpendicular magnetic field of, in perpendicular magnetic field of 2 Tesla. A square is kept in perpendicular magnetic field of 2 Tesla. If side length of a square, if side length of a square started increasing, if side length of a square started increasing at a constant rate of 1 meter per second, if side length of a square started increasing at a constant rate of 1 meter per second, if side length of a square started increasing at a constant rate of 1 meter per second, find EMF when side length becomes, find EMF when side length becomes 10 meter. Come on, everyone will do. Don't do mistake here. Yeah, okay, very good. So first write the flux at any time. What will be flux if side length is L? Yeah, answer will come 40. Again, write the value of flux. Flux will come, sir, ban. So B, how much B? B is 2. What is area of a square? Side square into BA into N. Nothing given. That means number of turns will be 1. Number of turns will be 1. Now, if someone is asking you EMF, you know d phi by dt. Differentiate it. So 2 L square differentiation will come 2L into dl by dt. Same there. If you differentiate here, we are differentiating not with respect to L. So don't think answer will come 2L. Answer will come 2L into dl by dt. Same process that I told you there. Now you can put the value. What is asked? What is this? Will become 2 into 2. This is 4L into dl by dt. Now 4L. What is L given? 10. And what is dl by dt? Rate at which length is changing. This is the rate that is given as 1. So answer will come 40 volt. Chamki baat? Well, everyone understood? Yeah, okay. So this is how we can talk about, all this. I'm giving you time of 15 seconds. Come on. See very fastly. So always remember, if you differentiate L square with respect to L, then it will give you 2L. If you differentiate with respect to time, it will give you 2L into dl by dt. Same thing you did in ray optics, when you are differentiating while finding velocity of object and velocity of image. You are differentiating 1 by v with respect to t. So that's why it was coming 1 by v square into dv by dt. So this is how we can talk about some questions where we change magnetic field. In some question we change area, we are changing area. And some question will be talking about when coil will be rotated. Be focused, understand how to get induced EMF if your coil will be rotated. You tell me, if you rotate the coil, then what will change? If coil is rotated, what will change? Theta will change. So we'll talk about that part. You write EMF due to rotation of a coil. Who is coming and going? If you are coming and going, go from other side. Class is going on, coming and going, in, out. What's going on? Yeah. Not serious about becoming doctor even. Nah, this is not how you'll become. Be serious when class is going on, going out. It's movie going. Yeah, online students are more serious. They are saying, sir, we are more serious. Yeah. So be serious when class is going on. Don't go out. If you don't have any emergency, if emergency is there, no problem. Yeah. So be focused here. Just see. EMF due to rotation of a coil. So just see here how we'll be talking about how EMF comes due to rotation of coil. Just see here how we'll be talking about. Assume one situation. Just see here. For example, if I'm saying like this, assume I'm having one coil. I'm having one coil. Okay. I'm saying this coil will have some area, sir. Okay, no problem. And sir, I'm saying magnetic field is like this. This is the magnetic field. This is the magnetic field associated with the coil. And this is the coil. Means coil is like this. Magnetic field is perpendicular. Yeah. Magnetic field is perpendicular to the coil. Okay, no problem. If you start rotating the coil, just see what happens. Just see here. I'll be simply saying, so right now, if you see area vector also like this now. This is our B vector, area vector also like this. Now, if you rotate the coil, for example, someone says, so this is the coil. I took the coil, I took this as axis and I started rotating the coil. So what happens actually when you rotate the coil, area vector also, for example, someone says, sir, if I took one axis like this and I started rotating the coil with some angular velocity omega, about this axis, I started rotating the coil with angular velocity omega. So what will happen if you rotate the coil with angular velocity omega, your area vector will also rotate because magnetic field is constant now. Your area vector is attached with the plane. So if coil is rotating, its plane is rotating. If plane is rotating, area vector is rotating. So if you rotate the coil, your area vector, see this is area vector now. This is area vector now. If you rotate the coil, area vector will also rotate. So I'll be simply saying, sir, initially if you see, if I say like this, sir, if coil rotated by an angle theta, area vector will also rotate by an angle theta. And if it is rotating with angular velocity omega, sir, this theta will be equal to omega t. Now you can see the new angle between your magnetic field vector and area vector. That is your theta. So you can write flux. Flux will be coming, as you know the value of flux, ban cos theta. And here what will happen? This will become ban cos theta. And what is your theta? Theta will be omega t. You know, whenever anything rotates with some angular velocity omega, and what is theta after time t? So theta will be equal to omega t. So when you are rotating the coil, area vector is also rotating. If your coil rotates by theta, your area vector will also rotate by same angle theta. And for coil, you can write theta equal to omega t. So same will happen. Now this is the EMF. If anyone, this is the flux. If anyone asks you EMF, you can write, sir, minus d phi by dt. Now if you differentiate it, minus will remain and this will become ban. Yeah, these are constant. And cos omega t differentiation, you know, you have studied. Yeah, you have studied about this differentiation in oscillations. Cos omega t differentiation will come minus omega sine omega t. During differentiation, coefficient of t is multiplied. During integration, it is divided. So same thing I'm talking here. So from here, if you see, this will become minus will become plus. So this will become ban omega sine omega t. And if you see, this is your AC EMF that you have studied. Just now you have studied AC chapter now. This is the AC EMF. There you wrote now V equal to V naught sine omega t. From there, from where that voltage comes? That voltage comes due to AC generator. When we rotate, you can see sinusoidal AC voltage that comes due to rotation of the coil. First, write this. EMF due to rotation of a coil. Someone is asking, sir, what is heading? EMF due to rotation of coil. So much frustration. Teacher completed the topic. Someone said, what's the topic? Wow, nice students. No, she got some net problem. Yeah. Ah. So this is the important part, and this is the AC. Yeah. This is the AC voltage, AC sinusoidal voltage that you have studied. It can be cos also. If I have started from, yeah, so both possibilities are there. Okay, no problem. Now understand. Now understand what is your need. What is your need? What will be asked here? Here it will be asked maximum EMF. If you remember, yeah, this is the principle of working of your AC generator. This is how AC generator works. A coil rotates in AC generator and we get AC voltage, due to which we get AC current. Now understand, yeah, E naught is your peak current. E naught is your peak voltage. Peak voltage, or you can say, sir, E naught is our maximum voltage. So question is asked, in need they will not ask you this equation. In need they will ask you what is the maximum EMF which can be obtained by rotating a coil, and that maximum EMF will come ban omega. This is the ban omega. You have to ban the omega. Don't allow omega to come. Ban omega. That is the maximum EMF generated. Very, very important point. You write this. This is the maximum EMF which you can generate by rotating a coil. Ban omega. Ban omega. Ban mummy. Ban papa. Ban omega. Ban brother. Ban sister. Yeah. Watch TV alone. Watch TV alone. Ban everyone. In the same manner, maximum EMF generated will be ban omega. Yeah. Yeah. Who is saying ban Sri Chaitanya? Who is that? Ban Corona. That's good. Ban Corona. That's good. Yeah. Okay. Okay. No problem. Yeah. So this is the maximum EMF which can be generated. This is most important. If you understand this or not, doesn't matter. No one will ask you this much complicated. Question, yeah. Question is asked. Come on, everyone will say, what is the maximum EMF generated by rotating a coil? What is Emax? Are bolo, ban omega, ban omega, ban omega, ban omega, ban omega. That is the maximum EMF which is generated by omega is the angular. And always remember this, omega will not be given to you directly in need. They will not give you omega. They will give you frequency. So you can always write this omega whenever required as 2 pi f. You add this also, come on. This is the frequency of AC that you study. That is the frequency with which coil is rotated. That is the frequency of AC that you study. Yeah. Now, one more point is there. One more point is there. That point is associated. You tell me. You tell me. Yeah. Okay. Okay. Now you write one point. You write one point. Achha, what is happening here? Here, when coil is rotating, the angle between magnetic field and area vector is changing. So for a particular angle, your EMF will become maximum. We'll talk about that. You write. You write. While generating EMF by rotating the coil, while generating EMF by rotating the coil, EMF becomes maximum. While generating EMF by rotating a coil, EMF becomes maximum when magnetic field is parallel to its plane. When magnetic field is parallel to its plane. When magnetic field is parallel to its plane and EMF generated becomes maximum when magnetic field is parallel to plane and minimum when magnetic field is perpendicular to plane. When magnetic field is perpendicular to plane. Understand what I'm trying to tell. Very conceptual part. If you want, you can directly remember also, but trying to bring understanding. Always remember. If you look at flux now, your flux is coming proportional to cos omega t. Your EMF is coming proportional to sin omega t now. Understand what I'm trying to tell? So one will come proportional to cos, other will come differentiation of it. So it will come proportional to sine. This will happen. Or either this will be sine, this will be cos. And if you see closely from here, the instant, so what is happening? Your flux will come proportional to cos. So EMF will come proportional to sine. If your flux comes proportional to sine, EMF will come proportional to cos. So what will happen? So if you see your flux and EMF, you know the place where cos becomes maximum, sine becomes minimum. For example, cos 0, 1, sine 0, 0, cos 90, 0, sine 90, 1. So always remember the instant your flux becomes minimum. If your flux is minimum, your EMF will become maximum. Now you tell me when flux becomes minimum. When flux become minimum, that is 0 when magnetic field is parallel to plane. You studied in the beginning. Your flux will be minimum when magnetic field is. So that's why your EMF becomes maximum when magnetic field is parallel to plane. Because flux comes with the help of cos, EMF is coming with respect to sine now. So when cos will be minimum, sine will be maximum. And cos will be minimum when magnetic field will be parallel to plane. When flux will be your when flux will be your 0. So at that time your EMF will be maximum. So always remember, you tell me when EMF generated by rotating the coil will be maximum. First, what is the value of maximum EMF? What is the value of maximum EMF? Ban omega. When that EMF maximum will be obtained? When that maximum EMF will be obtained? When magnetic field will be parallel to the plane. Because when magnetic field will be parallel to plane, flux will be minimum. And you know where the place where flux will be minimum, EMF will be maximum. EMF will be maximum because flux is depending on cos, EMF is depending on sine. Cos, sine both has reverse relation. So when flux becomes minimum, EMF becomes maximum. Your flux become minimum when magnetic field is parallel to plane. So at that time, EMF will become maximum. I'm giving you time of 10 seconds. Come on, see this part. Who came in the class? Robot. What's that? Hi, sir. Hi. So this is okay. You are there. So so this is how we talk about all these things. Okay, so two things you need to remember. Maximum EMF generated by rotating the coil will be ban omega. Second thing, your EMF generated will be maximum when flux will be minimum. And when that thing will happen, come on, tell me. This is the plane. This situation EMF maximum or this situation EMF maximum? First or second plane, which one? Sir, yeah, when plane is parallel to magnetic field, EMF generated will be maximum. So this is how we can talk about it. This is how we can do. I'll give you one more question. Come on, right? Now some questions are asked based on average EMF. Just see here, for example, they will say you like this. Understand? They will say you, this is a square coil which is having side length A. It is placed in perpendicular magnetic field. And they will say you, if someone comes and he changes the shape of a square coil from a square to circle, they will ask you find induced EMF. Can you find? You write, if the shape is changed, in time t, if the shape is changed in time t, find induced EMF. Yeah, Find induced EMF. So they are asking you for whole duration time t means they're asking you average EMF. So you can write initial flux, number of turns not saying, so you can say number of turns 1. Initial flux will come B into A. What is area now? A square. Final flux B into A. What is area now? Pi r square. So if anyone asks you magnitude of average EMF that is generated, you can write, so that will come minus of, yeah, final flux minus initial flux by T2 minus T1. Now you can do from here minus final flux B into pi r square. Initial flux B into A square upon T2 minus T1. That is given as T. This is the answer. But they will not give you radius. Radius you have to relate. Radius will not be given there. They will directly give you side length of a square, but radius you can relate now. Here total length will come 4a. Yeah, not 2a by pi. This will give you total a. You can relate with the help of perimeter. So here 4a and here length will come 2 pi r. So radius you have to relate. Yeah, 2a by pi. Yeah, radius will be coming as 2a by pi. And you can put that radius here. Where? Here you have to put and you'll get. Everyone understood? So this type of questions are asked. Yeah, okay. Oh, come on, do the last question. One more question I will talk about. Just we'll finish out this part. Some questions are asked like this. Some questions are asked like this. Just here. Okay, they will say you. There is a square coil. This is placed in this region. In this region, magnetic field is there. In this region, magnetic field is there. Okay, no problem. Square coil, side length A, side length A. They will say you, if a man comes and he takes out this coil from magnetic field to outside magnetic field, here no magnetic field is there. They will say you, he takes out in a time of t. During this time, find the average EMF. Come on. Chavandi, Targa, come on. Hey. How much average EMF? Yeah. So, Are Baba, average EMF will come. Initial flux was there. So you again find initial flux. So initial flux will come B into A square. Final flux, outside no magnetic field is there now. So what is your final flux? Final flux will be 0. So from here you can find EMF. EMF will come. So minus of delta phi, that is final flux minus initial flux by T. That we can find, so minus of final flux sunna initial flux B into A square by T minus plus. So this will come. This is the answer. Are bolo. You can find na Baba. Everyone understood? Yeah, come on, everyone say, otherwise I will give one more question. Come on. Everyone understood? Everyone understood 100%. Pakka. Yeah, okay. So this is how we have talked about. More situation we'll talk in next. Okay, bye. Do the question of material. I will come and I will check. Moving coil galvanometer must be completed by today. Bye. Sad.